This video is going to talk about the sum or the difference of like powers, and it's going to allow you to discover a pattern that will let you factor sums or differences of like powered polynomials. So you've already know how to do the difference of two cubes and the sum of two cubes. So now you'll be able to do 5th degree, 7th degree, 9th degree, and so on if you notice the pattern. And you might have already saw a small, the pattern starting up in the cubics, okay? So I'm going to prove this for you. So this pattern, and it's pretty cool. So what you can do for this is I'm going to use the rational root theorem to show that negative c is a 0 of this, okay? So if negative c is a 0, then if I plug in negative c for x, I should get 0. So negative c to the 5th power is going to be a negative c. And if I add c to the 5th power, I am going to get 0. So p of negative c is definitely 0. If p of negative c is 0, then that means that x plus c is a factor. Okay? And if x plus c is a factor, I could divide this into that polynomial and get my result and see how it factors. So I could either do long division, meaning I could do x plus c and divide it into this, which you've got to be careful. You got to have some place values here for the 4th degree. You'd have to look something like this: 3rd plus 0x squared plus 0x plus c to the 5th. So you could do this long division. And if you would like to do that, by all means, go and do that. I'm going to use synthetic division because I just think it's so much easier. So I'm going to take the opposite of this, negative c. So I'm basically going to show that negative c is a 0. I should get 0 for a remainder. I'm going to take the coefficients of all of these, so which is 1, 0, 0, 0, 0, and c to the 5th, because that's my constant. Okay, so now I'm going to do the synthetic division. Okay, just do the process and see what I get. I'm going to bring out a 1, so negative c times 1 is negative c. Add my column, that's negative c. Negative c times a negative c is a positive c squared. I'm going to add my column. Okay, negative c times a positive c squared is a negative c to the 3rd. So I add my column and I get this. Then negative c times negative c to the 3rd, I get c to the 4th. Add, I get positive c to the 4th. Negative c times c to the 4th, I get a negative c to the 5th. If I add that, I get 0 for my denominator, because remember I said negative c is a 0, so x plus c is a factor. So basically what I just did is I did this long division problem without having to go through the long division. So what I've shown is x plus c is a factor. Sorry, and then these are the coefficients of what's left. So this is always going to be 1 degree. This started with the 5th degree polynomials. This is going to be x to the 4th. Minus c, that's my coefficient, x to the 3rd, plus c squared x squared, minus c cubed x plus c to the 4th. Now I want you to look at the pattern. First of all, what's happening with the signs? We're going from positive to negative, okay? Then I want you to notice what's happening with the degrees of x. They're going down, 4, 3, 2, 1, 0, okay? The degrees of the constant are going up. 1, 2, well 0, if you want c to the 0 is 1, so you can put that there. C to the 1st, right there, squared, c to the 3rd, and then c to the 4th. So if you can follow this pattern, you can factor some pretty interesting binomials, okay, as long as they have an odd number power. They have to be the same. Okay, so I'm going to do an example, and then there's also a good example in your book, and you can look at that one after you look at this. Add a page here. So we are going to use that pattern to factor this, x to the 7th plus y to the 7th. Okay, we're going to factor that. So I've got x plus y is my first factor. Then I'm going to take this, I'm going to start with the 6th power. So I'm going to go back and show you something too interesting. And there's some really cool stuff with this. We're going to get into some stuff later. There's some all kinds of cool things. Sorry, it's not letting me go back. There we go. Notice that when you add the coefficients, 3 plus 1 is 4. 2 plus 2 is 4. 3 plus 1 is 4. So these are always adding up to 1 less than this, okay, which is kind of cool. All right, so I'm going to go back and I'm going to do my signs because they're going to alternate. Remember, so I'm going to have a minus and a plus and so on. Okay, so this is going to be an x to the 6th. So I'm going to start out with x to the 6th. Now my degrees for my x's are going to go down, and my degrees for my y's are going to go up. So my next one is going to be x to the 5th, y to the 1st. Okay, then I'm going to do a plus because I'm alternating signs. X is going to go down, y is going to go up. Alternate sign. X is going to go down, y is going to go up. Alternate sign. X going down, y going up. Notice these always add up to 6. Okay? Change sign, x going down, y going up, and I've got one more. Okay? So I just factored this, okay, using that pattern. And if this is a number, then just put the number here instead of the y to the proper power, and when you're all done, you can simplify. Okay, and there's a really good example in your book on page 352 that shows you how to do something like this, x to the 7th minus 128. Okay, so first of all, you have to write this as something to the 7th power. So x to the 7th minus, I believe it is 2 to the 7th. Okay, that's what that looks like. Now, what you're going to want to do is change this into an addition problem, and the book is going to walk you through that. So you're going to want to go like this. Okay, now you can follow this exact pattern right here. But instead of a y, I've got a -2. Okay, so make sure, and that's gonna change your signs a little bit, but you'll see how that works out. So check out that example on page 352 in your book, and I think this will help you be able to factor some of those binomials that are in your homework.